Hello, hello. We are back with Chapter 10, Probability, focusing on Lesson 8, Permutations, and this is the guided practice. So we're going to do a couple together, and then I'm going to give you a chance to work on some problems, and then we'll go over the answers. All right, so the first one says, Joe has homework assignments for math, Spanish, and history. And how many different orders can he do his homework? All right, cool. So there are three things. This would be what he does first, what he does second, and what he does third. All right? So for the option that he does first, as far as which homework he does, he has three options, right? So there's three things he can do. Okay? However, what we have to remember is he does one during this time. So whatever he does first, it's going to be one. One is going to go away. So when we go to what he does second, because he did one here and first, he only has two remaining options. And we have to remember, he does another subject right here. So he does another one right there. And then for third, because he did one of the assignments here, and he did another one of assignments, we don't know which one, and that's okay. We don't have to know. All we know is that he did one. So he did one first, he did another one second, which means there's only one option left for third. So what's cool about this is to figure out the number of permutations, all we need to do is just multiply these numbers together. So 3 times 2 is 6. 6 times 1 is 6. So there are 6 different orders to do his homework. All right, that's how that one works. Okay, let's do the other one. So number 2 says find the number of permutations of the letters in the word smart. So the number of permutations, all right. So SMART has 1, 2, 3, 4, 5 letters in it. So there's going to be 1, 2, 3, 4, 5. Okay, so this is the first letter. So for how many options are there for the first letter? Well, there's 1, 2, 3, 4, 5, because any of these letters can be first. So there's really 5 options for the first letter. What about for the second letter? Well, we have to remember that one of the letters got used in this first letter. So, since that is the case, there are only 4 options left because one of the options are currently here. We don't know which one, and that's okay. We don't have to. All we know is that one of them is in this spot, okay? So, yeah. So, when we get to the next letter, here, this would be the third letter. So this is the first letter, the second, the third, the fourth, and the fifth, okay? When we get to the third, well, we know that one letter is already here and another letter is already here. So that means there are only 3 of the letters left as options, okay? And one letter is now going to occupy this spot. So when we get to the fourth letter, there were originally 5 letters, but one letter's here, another one's here, and another one's here, which means there's only 2 letters left. Okay, and then finally we get to the fifth letter, and there's only 1 letter left because one letter is here, 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 here. So there's already 4 letters right here. So there's only 1 letter left over. So there's only 1 option for that 5th spot. Now, with permutations, all we do is just multiply all these together, and we end up with a big number. 5 times 4 ends up being 20, right? 20 times 3. Oh, I shouldn't do that right there. Let's do it over here. 20 times 3 is 3 times 0, 0. 3 times 2 is 6, is 60. And so then we have to multiply it by 2. 60 times 2. I should probably rewrite that. 60 times 2. 2 times 0 is 0. 2 times 6 is 12, is 120, and then 120 times 1 is just 120. So there's 120 permutations. Let's see if I can fit that in. Permutations. I'm running out of space. Permutations. Right there, 120. You know what? I want to tell you something. When you have something like this, 5 times 4 times 3 times 2 times 1, there's actually a different way to write that. 5 times 4 times 3 times 2 times 1 is the same thing as 120, but sometimes people, they don't want to write all that, so they just write this, 5, and they use this exclamation point, and that means factorial. Right? So that is 5 factorial. If you ever see exclamation after a number, that means it's that particular number multiplied by all the numbers that came before it. So, you know, 5 factorial isn't that big of a deal, but if I had to like start at like, I don't know, 100 and write all the numbers that went before it, 97, and so I, you know, and I have to keep going all the way down to 1, it's way easier, etc. And then it goes to, you know, 3 times 2 times 1. So 100 times 99 times 98 times 97 times 96 times 95 times 94, 94, blah, 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 times 3 times 2 times 1, all the way down there. A much easier way to write that would be 100 factorial. So that's what that means right there. It's not a really excited 100. It's just 100 multiplied by all the numbers that happened before it. Okay, cool. So now it is your turn. I want you to go ahead and work on problems 3 and 4. Where's my friend? Where's my friend? Oh, here's my friend. Reminding you to pause your device and go ahead and work out 3 and 4. And when you get done, press play and we'll talk about the answers. All right, see you in a bit. Okay, we are back. Let's go ahead and talk about problem 3. Problem 3 states, in how many ways can you arrange the numbers 6, 7, 8, and 9 to make a 4-digit number? Okay, cool. So we have one digit here. This is another digit, and another digit. So this is the first, second digit, third digit, fourth digit, right there. Okay? So out of these numbers, there's 4 numbers, right? 6, 7, 8, 9. How many options do we have for this first digit? Well, it could be any of these 4, so we have 4 options, okay? But we have to remember that once something goes in that first spot, one of the numbers is permanently going to be here. We don't know which one, we don't need to know, but there's gonna be one there. So that means in the second digit, how many options are left? Well, we started with 4, but because one of the digits is going to be right here, we only have 3 digits left. And then we have to remember that there's going to be a digit occupying this spot. So when we get to the third digit, we started with 4 options, but there's 1 in this spot, there's another digit in this spot, so that means there's only 2 digits left, which now means that there is 1 digit occupying this spot. So when we get to the 4th spot, we started with 4, but there's 1 digit here, 1 digit here, 1 digit there. So that means there's only 1 digit remaining. So then we just multiply them. And we multiply them and go 4 times 3, which is 12, times 2, which is 24, times 1, which is 24. So, and how many ways can you arrange the numbers 6, 7, 8, 9 to make a 4-digit number? 24 different ways. Boom, right there. Okay, cool. And then we have 4 times 3 times 2 times 1. Does anybody know another way to write that? Well, you would write that as 4 factorial. Just a little fun fact. Okay, let's go ahead and move on to problem 4. So, problem 4 says a table has 8 seats. In how many different ways can 8 people sit at the table? Okay, cool. So we have 8 seats. So this is going to be seat 1, seat 2, seat 3, seat 4, seat 5, seat 6, seat 7, seat 8. So this is seat 1, seat 2, seat 3, seat 4, seat 5, 6, seat 7, and seat 8. So there's 8 people. So how many people could sit in this first seat? Well, there could be 8 people. There's 8 different options. 8 people could sit there, but we have to remember that once there's going to be only one person actually sitting there, right? So when we go to the second seat, how many people could sit in this spot? Well, there's one person that's going to sit here. We started with 8 and one person's sitting here, so that means there's only 7 people left. 7 options left for that particular seat. And now there's another person sitting in this seat. So then we go to the third chair or seat, and we want to figure out, well, how many people could sit here? Well, we started with 8. There's one person already sitting here, another person already sitting here, which means there are only 6 options left. But now there's a person sitting here. So then we go to the fourth seat. We started with 8. There's one person here, one person here, one person there, which means there's only 5 people left to choose from. And now there's a person sitting in this seat. So we go to the fifth seat, and we started with 8, but now there's already 4 people sitting here, which means in their seats, so there's only 4 people left to choose from. And now there's a person sitting in this seat. Then we get to the 6th seat. And there's already 1, 2, 3, 4, 5 people in their seats. And we started with 8, so that means there's only 3 people left. 3 options left, but now there's a person sitting in this seat. Then we go to the 7th, right? We started with 8, but there are 1, 2, 3, 4, 5, 6 people already sitting down, which means there's only 2 people left. And then now there's a person sitting in that seat, which means there's only 1 person left to sit in that last seat. And the cool thing about this is we just multiply all these numbers together, like that. So we are going to get a big number. This is going to be 8 times 7 is 56. And this is going to equal, maybe I'll do my work over here. So 8 times 7 is 56. Okay, and 6 times 5 is 30. So I'm going to multiply this by 30. Okay, so I get 0 times 6, which is 0 times 6 is 0. Oh, it's just a 0, so now I can move to the tens. 3 times 6 is 18, write the 8, carry the 1. 3 times 5 is 15, plus 1 is 16. Okay, so there you go. So that's 8 times 7 is 56, 6 times 5 is 30, and then we have 4 times 3, which is 12, times 2, which is 24, times 1 is 24. So I can take this number right here and just multiply it by 24. 4 times 0 is 0. 4 times 8 is 32. Write the 2, carry the 3. 4 times 6 is 24, plus 3 is 27. 4 times 1 is 4, plus 2 is 6. And now I'm in the 10 spot, so I'm going to write a 0 in the 1 spot. 2 times 0 is 0. 2 times 8 is 16. Write the 6, carry the 1. 6 times 2 is 12, plus 1 is 13. Write the 3, carry the 1. 2 times 1 is 2, plus 1 is 3. And then 0 plus 0 is 0. 2 plus 0 is 2. 7 plus 6 is 13. Write the 3, carry the 1. 6 plus 3 is 10, plus 1. No, 6 plus 3 is 9, plus 1 is 10. Sorry about that. Write the 0, carry the 1. 3 plus 1 is 4. So there we have it. Oh my goodness, that's 40,320 different ways people can sit at a table. That's a lot of different ways. I'm just going to be the first one to say that, or maybe you said that already. But if you got that right, awesome job. Perfect. Okay, let's move on to the next page. So we have 5, problem 5. It says 9 mountain bikers are on a bicycle trip, and how many possible ways can they follow each other? So what I want you to do is I want you to go ahead and work out these problems, 5, 6, 7, and 8. Okay, go ahead and work out those problems on your own. So here's my friend, the pause dragon, reminding you to pause your device, work out problems 5, 6, 7, and 8, and then when you get done, press play and we'll talk about them. All right, see you in a bit. Okay, we're back. Let's go ahead and talk about problem 5. It says 9 mountain bikers are on a bicycle trip, and how many possible ways can they follow each other? Okay, so that means there's going to be someone first, there's going to be someone second, someone third, someone fourth, someone fifth, someone sixth, someone seventh, someone eighth, and someone ninth. Okay, all right. So 9 mountain bikers are on a bicycle trip. So how many people could be in first? Well, any of the 9 could be, right? So there's 9 options there. What about second? Well, somebody's in first, so that means there's only 8 options left. What about third? How many options are there for third? Well, there's 2 people, 2 bikers in those 2 places, which means there's only 7 options left. And fourth, there's already 3 people here, so that means there's 6 options. And then for fifth, there's 4 people here, so 9 take away 4 means there's only 5 options left. And then for sixth, there's only going to be 4 options, and seventh, there's only going to be 3, and eighth, there's only going to be 2, and ninth, there's only going to be 1 option left. And then we just multiply all these numbers together. And that is quite a bit of multiplication. So I know from the last problem that we did, what did we do? We did, let me put it down here. We already figured out that 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is 40,320. And that 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, that is the same thing as 8 factorial, right? So what I know is I know that 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is actually equal to 40,320. And that's what this is, right? That's 8 factorial. That is the same thing. So now I just need to multiply it by 9, and I can figure out my answer. Okay? So that's what I'm going to do. 9 times 0 is 0. 9 times 2 is 18. Write the 8, carry the 1. 9 times 3 is 27, plus 1 is 28. 9 times 0 is 0, plus 2 is 2. 9 times 4 is 36. So there we have it. We have 362,880 possible ways. And that's a lot of ways. Okay, so if you got that right, awesome job. Let's move on to the next. Problem 6. Problem 6 says 7 students are waiting in line at a cafeteria. And how many different orders can they be standing in line? Okay. So we're going to have somebody in first, somebody in second, somebody third, somebody fourth, fifth, sixth, and seventh, right? Because there's 7 people. So first, second, third, fourth, fifth, sixth, and seventh. So for the first spot, how many options are there? Well, there's 7 students, so anybody can be there, any of the 7. For the second, because somebody's here, there's only 6 options left. For the third, because there's 2 people here, there's only 5 students that could be here. For the fourth, because there's 1 person here, 1 person here, 1 person here, there's 3 people in those spots, so 7 minus 3 would be 4. And then for the fifth, we have 4 people here, so that would mean if we started with 7, there'd only be 3 left that could be in this spot. And now there's only going to be 2 people that are going to be able to be in this spot and 1 person that's going to be able to be in that spot. And then we just multiply them all together. And we get 7 times 6, which would be 42, right? And then 5 times 4 is 20. And 20 times 3 is 60. And 60 times 2 is 120. So we're going to have 120 times 42. So 2 times 0 is 0. 2 times 2 is 4. 2 times 1 is 2. Write the 0. 4 times 0 is 0. 4 times 2 is 8. And 4 times 1 is 4. And then we add 4. That's 10. And that's 5. So we end up with 5,040 different orders. So there we go. Very, very cool. Okay, if you got that right, awesome job. Okay, so let's look at how many permutations of the letters A through F are there. Okay, so A through F. How many different letters is that? So I'll just go A, B, C, D, E, F. Okay, cool. There it is. So this would be the first letter. This would be the second letter. This would be the third letter. This would be the fourth letter, the fifth letter, and the sixth letter, right? A, B, C, D, E, F. Okay, so we're talking about 6 different letters between A and F. So how many options could be here? Well, there could be 6 letters. Any of those 6 letters could go in the first spot. Okay, what about the second spot? Well, 1 letter is going to be here. We have a total of 6, so that means there's only 5 that are remaining as options to be in this spot. So let's go to the third. Well, we have 1 letter here, 1 letter here. We started with 6. Now we only have 4. Okay. And then we go to the 4th spot, and there's a letter here, a letter here, a letter there. That's 3 letters. We started with 6. That means there's only 3 left. And then for the 5th spot, there's 4 letters in this region, which means if we started with 6, there's only 2 remaining. And then finally, there's 5 letters here. We started with 6, so there's only 1 letter left that can be in there. We don't know which letter, but it doesn't matter. We just know it's 1 option. So then we're just going to multiply all these together to find the number of permutations. Okay, so we can go 6 times 5, which is 30. And then go 4 times 3, which is 12, times 2, which is 24, times 1 is 24. So I'm actually going to put the 0 on the bottom, because the 30 on the bottom, because it makes the problem easier. And 0 times, we just put the 0, and then we can go 3 times 4 is 12, write the 2, carry the 1. 3 times 2 is 6, plus 1 is 7. So there's a total of 720 permutations. Okay? And just to recap, if we go back up to 5, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is another way of writing 9 factorial. So 9 factorial is the same thing as 362,880. If we go down to problem 6, 7 times 6 times 5 times 4 times 3 times 2 times 1 is the same thing as writing 7 factorial. And 7 factorial is the same thing as 5,040. And the problem that we just did, 6 times 5 times 4 times 3 times 2 times 1 is the same thing as writing 6 factorial. And that is also equal to 720. Okay, cool. Let's move on to 8. 8 says, Ed, Martine, Sal, Carl, Paula, Terry, Ken, Leo, and Ursula, and Jamie are in a race. Oh my goodness, that's a lot of people in a race. And how many different orders can they finish? Okay, so how many people do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Holy goodness. Holy goodness, that's all I'm going to say. Holy goodness. Okay, so there's 10 different places. Woo! Let's go. Let's do this. Okay, so there's, that's going to be first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. So first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th place. Okay, So let me recount this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so how many of these people could get first? They all could get first. So that means there's 10 options. Okay, how many people could get second? Well, one person's here, which means there's only 9 options left. What about third? Well, there's going to be a person here and a person here, which means those are 2 people that are going to be in those places. So there's only 8 people left that could be in third place. For fourth place, there's 3 people occupying these positions, which means there's only 7 people left that can come in fourth as options. For fifth, there are 1, 2, 3, 4 people here. So out of 10, there's only 6 people left that can be in fifth. For sixth, there's 1, 2, 3, 4, 5 people here. So out of 10, if we go 10 minus 5, there's only 5 options left that people that can be here. For seventh, out of 10 total people, there's a person here. 1, 2, 3, 4, 5, 6 people in these positions. So if you go 10, take away 6, there's only 4 people left that can occupy that spot. And then there's only going to be 3 people that can occupy this one, and 2 that can occupy this one, and 1 that can occupy this one. So, and then we just multiply all these together, that's a lot. That is a lot. But what I do know is I do know that 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 equals 362,880. And that is the same thing if we take away this 10, right? If we go 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, that is the same thing as this, which equals that. So really, I know that all of this equals this, so now I just need to take that and multiply it by 10. So I'm going to take 362,880 and multiply it by 10. So, oh, you can't even see it. Okay, there we go. So I'm going to put a 0 here first, and then I'm going to go to the tens place. And then I go 1 times 0, which is 0, 1 times 8, which is 8, 1 times 8, which is 8, 1 times 2, which is 2, 1 times 6, which is 6, 1 times 3, which is 3, and boom, we have our number of options, which is 3,628,800 different orders. That is a lot of different orders. That's really, really, really a lot. So if you got that one right, awesome job. Okay, perfect. Let's move on to problem 9. So for problem 9, I want you to go ahead and, actually, I just want you to go ahead and do all these, okay? So try problems 9, 10, 11, and 12 on your own. And so where's my friend? Oh, there's a pause dragon. Remind you to pause. And when you get done, go ahead and press play, and we will talk about the answers and see how you did. All right, see you in a bit. You can do it. I believe in you. Okay, we're back with problem 9. Problem 9 states, find the number of permutations of the letters in the word recognizably. That's a lot of letters in that word. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whew! That is a lot of letters. Okay, there's 12 letters. Let me make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, 12. We can do this. 12. 12 letters. Okay, here we go. So this is going to be the first letter and the second letter and the third letter and the fourth and the fifth and the sixth and the seventh and the eighth and the ninth and the 10th and the 11th and the 12th. Okay, so first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, and 12th. Okay. All right. Here we go. Here we go. Okay. So, how many different letters could go first? Well, there's 12 options, so there's going to be 12 that could go here. And then there's going to be one letter, which is going to mean that there could be 11 here. And then you have 2 letters, which mean 10 could be there. And then 9, and then 8, and then 7, and then 6, and then 5, and then 4, and then 3, and then 2, and then 1. And then you multiply them all together. Okay, like that. like so, like so. And then, yeah, we just need to multiply all those. We know from our last problem that 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 equals 3,628,800. Right? Yes, it does. Okay? So that is the same thing that 10 times 9, these are the same thing. 10 times 9 times 8 times 7 times 6, that's the same thing as this. And all of this equals that right there. Okay, that number. So we know that. So if we just figure out what 12 times 11 is, 12 times 11, 1 times 2 is 2, 1 times 1 is 1, 1 times, oh, then we go to 10, so we got to put a 0. 1 times 2 is 2, 1 times 1 is 1. So we end up with, we add 2 plus 0 is 2, 1 plus 2 is 3, and then 1. So then we just need to, those two equal 132, so we can just multiply this by 132. And we will get our answer. Okay? All right, here we go. 2 times 0 is 0. 2 times 0 is 0. 2 times 8 is 16. Write the 6, carry the 1. 2 times 8 is 16. Plus 1 is 17. Carry the 1. 2 times 2 is 4. Plus 1 is 5. And 2 times 6 is 12. Write the 2, carry the 1. 2 times 3 is 6. Plus 1 is 7. And then we're going to the tens place, so I need to put a 0 here. 3 times 0 is 0. 3 times 0 is 0. 3 times 8 is 24. Write the 4, carry the 2. 3 times 8 is 24. Plus 2 would be 26. 3 times 2 is 6. Plus 2 is 8. 3 times 6 is 18. Write the 8, carry the 1. 3 times 3 is 9. Plus 1 is 10. Okay, now we're in the 100 spot, so we need to have 2 zeros there. Okay, 1 times 0 is 0. 1 times 0 is 0. 1 times 8 is 8. 1 times 8 is 8. 1 times 2 is 2. 1 times 6 is 6. And 1 times 3 is 3. Now we just add up all these numbers and all the space I have here. Okay, 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. 6 plus 0 plus 0 is 6. 7 plus 4 is 11. Write the 1, carry the 1. Okay, 8 plus 6 is 14, plus 5 is 19, plus 1, did I say that right? Yeah, 8 plus 6, 14, plus 5 would be 19, plus 1 would be 20. Write the 0, carry the 2. 2 plus 8 is 10, and 8 plus 2 is 10, so that's 10 plus 10, which is 20. Write the 0, carry the 2. 8 plus 2 is 10, and then 7 plus 2 is 9, so that 10 plus 9 is 19. Write the 9, carry the 1. 1 plus 6 is 7, and 1 plus 3 is 4. So we end up with, 479,001,600. Now, I want to go ahead and check this number. And so, how you can do it is by, just putting all the numbers in. 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Enter. And we have 479,001. Yeah, 479,001,600. And another way you can do it is if you you type in 12, because what is this known as? 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's the same thing as 12 factorial. So you could just put 12 in there, and then you go up to probability, and you go over to, can you see that? That factorial sign. So you go over, enter, So now it says 12 factorial, and then you just hit enter, and boom, there we have our answer right there. 479,001,600. So that's another way to do it, just to check. Okay. Yeah. All right. So let's go ahead and look at problem 10 and see how you did. Problem 10 says, in how many different orders can 11 people stand in line? Okay, 11 people standing in line. How many different orders? Let's figure it out. So we're going to have somebody in first, someone in second, someone in third, someone in fourth, someone in fifth, someone in sixth, someone in seventh, someone in eighth, ninth, 10th, 11th. Okay, so this is first, second, third, fourth place, fifth, sixth, seventh, 8th, 9th, 10th, and 11th. Okay. All right. Cool. So there's 11 people. How many people could be in first? There's 11 that could be here. How about in second? Well, since somebody's there, there's going to be only 10 options for second in line. What about third? Well, there's 2 people here, so out of 11, that means there's only 9 options left. What about fourth? Well, there's only going to be 8, and then 7, and then 6, and then 5, and then 4, and then 3, and then 2, and then 1. And then we multiply them all together. Like that. And then we just want to figure this out, and we know that all of this is the same thing as 11 factorial, right? Right? So I'm just going to go to my calculator, and I'm going to go 11, and I'm going to go probability. I'm going to go over to the factorial. I'm going to hit enter. And that's what it should be. Three, 9, 9, 1, 6. Let's zoom in here. Zoom in over here. Can you see? It's kind of hard to see for some reason. There. Is that better? Yeah, it's better. 3, 9, 9, 1, 6, 8, 0, 0. All right. And there we go. There's our answer. So if you got that one right, great job. Okay. Okay, 11 says, in how many different ways can a librarian arrange 8 books on a shelf? Okay, so there is the first place, the second, the third, the fourth, the fifth, the 6th, the 7th, the 8th. First, second, third, fourth, fifth, 6th, 7th, and 8th. So how many books can be in the first place? Well, there can be 8 books there. What about in the second place? Well, since there's a book here, there's only 7 books that can be here. What about the third place? Well, there's a book here and a book here. So that means there's only 6 books left that can be in the third one in line. What about the fourth? Well, we have a book here, a book here, a book here. So that would mean that there's only 5 that can be in this spot, and then 4, and then 3, and then 2, and then 1. And we multiply them all together like this. And this is the same thing as 8 factorial, right? But we can just, did we do one with 8 factorial yet? Yeah, we did. This one was 8 factorial, and we already figured it out. The problem before, let me zoom out here. Problem 4 is the same thing as 8 factorial. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's the same here. So we know that 8 factorial is the same thing as 40,320. All right, cool. Okay, so Melinda has 12. It says Melinda has 15 art trophies. Write an expression that shows how many different ways she can line up her trophies on a shelf. Okay, so we are supposed to write an expression. That's what they're asking us to do. Not figure out the problem, just write an expression. So, and how many different ways she can line it up, the trophies on her shelf. Okay, so there's going to be the first in line, the second, third, fourth, fifth, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th. Holy goodness. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay? So how many of these 15 trophies can be the first in the first in the row? Well, 15 of them, any of them can be, and there's 15 options. However, one book's going to be here, or one, what are we talking about? Art trophies. One trophy is going to be here. So the second one in the row, that means there's only 14 options, and then it's going to be 13, and then 12, and then 11, and then 10, and then 9, and then 8, and then 7, and then 6, 5, 4, 3, 2, 1. They're all multiplied by each other like this, and it just wants to know the expression. So what's another way we can write this? 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Whew! We can write this as 15 factorial. So if you wrote that one, great job. Okay, let's move on to the next page. Okay, problem 13. Problem 13 says, in how many ways can you arrange the letters in the word now? List the permutations. So, what we're going to do is we're going to write a tree for this problem. We're going to make a tree. So, one way, so we have to list it. So we're not just figuring out all the, like the number of permutations. We have to list all the permutations, okay? So, we could have n could be first, right? Now, if n is first, this is first and second. What could be second? Well, there's two options for second. It could be O or it could be W, right? Those are the two options. Now, if we go N-O, that means in third would have to be W, right? And if we go N-W, third in line would have to be O. All right? Okay, so we have N-O-W. That would be one in the list, would be N-O-W. And another one in the list would be N-W-O. N-W-O. Okay, but let's say instead of starting with the letter N, we start with the letter O. Well, if we start with the letter O in first place, then what could be second place? Oh, whoops, that wasn't meant to be connected. Well, we could either have an N or we could have a W, right? Now in third, if we have an O in first, an N in second, then W would have to be in third. And for the other option, if O is in first and W is in second, then N would have to be in third. So now we have two more options. We have O-N-W, O-N-W, and also O-W-N. Now for the, so we had with N first and then O first, but we could also have W first. Now if W is first, there are two options. There's only two, right? So if W is first, you could either have O second or no, not W, W's first, or N second. Okay, now if W's first and O is second, then that means that N has to be third. And if W is in first and N is in second, then that means that O would have to be in third here, which gives us two more options, W-O-N and W-N-O. So that means we have 1, 2, 3, 4, 5, 6 options, and that is the list of options, which makes sense because we have three letters, right? 1, 2, 3, and this would be first, this would be second, and this would be third. And so how many options could be in this first letter? Well, there's 1, 2, 3 letters, so 3 could be here, right? How many could be in second place? Well, because one letter's here, only 2 could be there. And then in third, there's a letter here and a letter here, which means there's only one letter left over. And if we multiply all those, 3 times 2 is 6, times 1 is 6, which is the same number of options in our list. 1, 2, 3, 4, 5, 6. Okay? So, now I want you to go ahead and try 14 and 15. So go ahead and pause your device and work those problems out. And when you get done, press play and we'll talk about them. All right, see you in a bit.